Okay, now see, I have done under inequalities, polynomial inequalities and rational inequality part, no? Polynomial inequalities and rational inequality part. So I did the things with a number line. I did the things with number line. But you better to follow another technique. I'm going to tell you another technique to evaluate a rational inequality and polynomial inequality. That is another technique. Okay, first check that one. Check this. You consider x minus 1 greater than 0. X minus 1, x minus 2 less than or equal 0. X minus 1, x minus 2 less than or equal to. Here consider x minus 1, x minus 2, x minus 3 greater than 0. Here x minus 3, x minus 1, x plus 1 times x less than or equal 0. All are polynomial type inequality. So this method we can apply for both rational and polynomial types. So anyway, identify here we have one factor, here we have two factors, here we have three factors, and here we have four factors. No? All are polynomial type, linear inequality, here quadratic inequality, here cubic inequality, and there biquadratic inequality, and so on. We can consider many more polynomial types. Then all we say polynomial inequalities. Okay, that number line technique, that is okay. But when you are doing term test questions, then you better do our new technique. See that one. So I'm doing this one with a table. Here I'm do first two together. Here mark real number line. Here factor 0 value is 1. Mark it. Here real number line. Factor 0 values 1 and 2. Now you create a table like this. Here we have 3 columns. We have 3 sections now. Here we have 2 sections, 2 columns. We have 3 sections, 3 columns. So on. Now you put 1 here. Then value greater than 1. Values less than 1. Value greater than 1, value less than 1. Okay. Now we have one factor now. We write here x minus 1. For value greater than 1, you say this one positive. Value greater than 1, say this one positive. Then for value less than 1, you say this factor negative. No? Value greater than 1 means you take x equal 2, 3, 4, those values and substitute here, check sign. Then that is positive. No? Positive. Then for value less than 1, here this one negative. No? Negative. So we need to consider here positive regions. Here positive regions is this. Then you take this one as the solution. Then finally x less than 1. Then final answer, x element of real set x such that x greater than 1. That's how we do. So previously we did that one with number line. Now go to this. Here we have 2 columns, 3 columns, put 2 and 2, 1 and 1. Values greater than 2, values in between 1, 2, value less than 1. Now here we have 2 factors. Now. Then smallest one is 1. The corresponding factor x minus 1. You better write that one here. Then next 2. Then corresponding factor x minus 2. You write here. Now individually you find signs. Just find signs. Then for value less than 1, here this factor negative. Value in between 1 to 2, here this factor positive. No? Value greater than 2, here this factor positive. No? Check it again. Value less than 1, take 0, substitute here, we get negative value. 1 to 2, take 1.5, substitute here, we get positive value. Greater than 2, take 3, substitute here, we get positive value. Then for x minus 2 factor, when you get x minus x less than 1, this will be negative, and here positive. We need to multiply them. We need to multiply x minus 1, x minus 2, then product positive, product negative, product positive. I told you when you are doing number line thing, right hand corner, we start up, right hand upper corner, no? Like this. No? Then always right hand corner one will be positive. That's why I told you to start there. Then plus, minus, plus. We need negative values. We need negative values. Then you select this one, then corresponding solution is this. And further we have equality. To get that equality, you put equal signs here. Each case you put equal signs. Final answer, x element of real set, x such that x in between 1 to 2 with equal 1 and equal 2. Okay. Then same procedure we can develop. See this one. For 3 factors, you do this say, sketch number line, here 0 value 1, here 0 value 2, here 0 value 3. Now get a table. Here 3, 3, 2, 2, 1, 1, less than 1, in between 1 to 2, in between 2 to 3, greater than 3. Now here we have 3 factors, smaller value 1, corresponding one x minus 1, you start there x minus 1, here x minus 2, then x minus 3. Okay, then you put values and check the signs. So if you write that order, then here minus, plus, 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 this will happen. Then minus, minus, plus, plus will happen. You need to shift one by one minus signs. Then minus, 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 plus. Now need to check. If you write that order, we can get that table. Then we need to multiply 3 factors, x minus 1, x minus 2, x minus 3. Then here product will be plus, here minus, here plus, and here product minus. We need to think about positive regions here and here. Then corresponding regions are here. Then final answer, x element of real set, x such that x in between 1 to 2, union, we have 2 separate regions, then you put union, x value greater than 3. Okay. So you better to get table when you are evaluating inequality now onwards. Okay. Then here for 4 factors, you can extend that thing. Here real number line, here 0 value 3, 1, and 0, minus 1. Then we have 5 columns here, 3, 3, 1, 1, 0, 0, minus 1, minus 1. In between minus 1 to 0, in between 0 to 1, in between 1 to 3, greater than 3, less than minus 1. Then you better to start with this corresponding factor x plus 1. Then next 0 is x. Then next 1 is x minus 1. And the next x minus 3. X minus 3. So here this will be minus, plus, 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 minus, minus, plus, 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 minus, 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 plus, plus, minus, 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 plus. Okay, if you wrote that order, this table we can easily write. Okay, no need to check, we can just put. So anyway, thereafter we have to multiply every factors here. We have to multiply. Here x minus 3, x minus 1, x plus 1, and x. So when you multiply, here plus, minus, plus, minus, plus. No? Then finally negative region, here and here. We have 2 regions, and further we have equality. Put equality here. Then finally negative region, you select table headers. x element of real set x such that x in between -1 to 0 with equal sign union x greater than or equal 3. Here it is. Okay, that's how we evaluate polynomial inequality. This is second technique. When you are doing questions, you better do for direct questions. Okay, for direct inequality questions, you better do here this technique. Okay, write that second technique. Start from here. For rational part also you can do same. Complete all. Okay, do last one as well. Last one answer wrong. In between 1 to 3, ne? In between 1 to 3 with equal. Now let's see how to do for rational inequalities. You can follow same thing. Huh? Check this. X minus 1, x minus 2, x plus 1 times x less than 0. Less than 0. Here real number line, mark zeros here. Here 2, here 1, here 0, and here minus 1. Likewise mark them. Then corresponding to that, you get a table. Here put 2, 2, 1, 1, 0, 0, minus 1, minus 1. Then value less than minus 1, value in between 0 to minus 1 to 0, in between 0 to 1, in between 1 to 2, greater than 2. Now separate each factor. Here you better to start at minimum. Here minus 1 corresponding factor is x plus 1. Then next 0, you put 0 here, sorry x here. Then 1 corresponding one x minus 1, 2 x minus 2. Likewise you better to put them ascending order. Now according to our method, so you can check these signs by substituting values, but it takes some time now. Then you better to do that order, then put directly minus plus 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 plus, minus minus plus plus plus, minus 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 plus plus, minus 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 plus. Okay, no need to check. If you write that order, we can easily fill the table. Then x minus 1, x minus 2, x plus 1. So we have to multiply 2 and again divide by 2. Anyway, it's just like again multiplication. Then here division for these two division, these two for numerator, no? Then that get plus minus plus minus plus. Then we need negative regions. So here and here the answer. X element of real set x such that x in between -1 to 0, x in between 1 to 2. Likewise, we can complete. Okay. So, but for rational inequality, we need to think about denominators. But here, no worries, we don't have equal here, no? Then no need to think lot. But if we have equal here, then we have to think lot. Okay. For now, you do this one, then later we do with equality. Complete it. Okay. Now you see another one. Here x over x minus 1, x minus 2 less than or equal 0. So we have equality now. Now anyway, we know for rational relation, we have to remove denominator zeros, no? Denominator zeros. Then here real number line, mark zeros here, 0, 1 and 2. 0, 1, 2. We have equality, but denominator 0, 1 and 2 you have to remove. Then numerator 0 can be selected, no? Okay. Then denominator 0 you remove. Numerator zeros you select. Then 1, 1, 2, 2, 0, 0, less than 0, in between 0 to 1, in between 1 to 2, in less greater than 2. So now equality only 0, mark equality for that, not for the others. Okay. Definitely you have to remove denominator zeros. You think only about numerator zeros. That's it. Then usual way, now you can put signs. Before that, here 0 corresponding factor x, then 1 corresponding factor x minus 1, then 2 corresponding factor x minus 2. So if you write that order, we can put signs here, minus plus plus plus, minus minus plus plus, minus 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 plus. No? So now we have to think about this relation, x over x minus 1, x minus 2. So anyway, it's like a product again. So we have that in denominator, but anyway, you can think with product. Here plus, here minus, here plus, here minus. No? So according to this one, you can put minus, 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 then all negative. Then negative regions here and here. Then final answer, x element of real set x such that x less than or equal 0, union x in between 1 to 2. Okay, that's how we do. Complete that. Okay, after that you try these questions, not only using number line, you use that table tabulation technique. Okay, continue now. While you are doing, check your answers. I'll do 2, 3. We have 4 now. I'll do first 2. Yeah, x minus 3, x plus 1, 2x minus 1 greater than 0. Mark on the number line. Here 3, here half, here minus 1. Get a table. 3, 3, half, half, minus 1, less than minus 1, in between minus 1 to half, in between half to 3, greater than 3. Then start with minus 1, that is x plus 1 factor, 2x minus 1, x minus 3, minus plus plus plus, minus minus plus plus, minus 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 plus, then x minus 3, factor product now, x plus 1, 2x minus 1, minus plus minus plus. Then here positive, positive. Then x element of real set x such that x in between minus 1 to half union x greater than 3. X greater than 3. Second one, 3x minus 1, x plus 2, 2x minus 1 over x greater than 0. Then mark them. Here minus 2, 1/3, 0, 1/3, half. Half, half, 1/3, 1/3, 0, 0, minus 2, less than minus 2, in between minus 2 to 0, in between 0 to 1/3, in between 1/3 to half, greater than half. So we have factor product now. Before that, minus 2 corresponding factor x plus 2, then x, then 3x minus 1, then 2x minus 1. Minus plus 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 plus, minus minus plus plus plus, minus 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 plus plus, minus 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 plus. Then here 3x minus 1, x plus 2, 2x minus 1 over x. Then plus minus plus minus plus. We need positive. We have 3 sections. Final answer x element of real set x such that x less than minus 2 here. Union 0 to 1/3. Union x greater than half. That is second one. Here no need to think about zeros now. Because equal not given, then no need to think about zeros now. Okay, the next, so we have x plus 5, 2x minus 3, x minus 2 over x minus 1 less than or equal 0. There's equality, we have to think. Real number line, here minus 5 and here 0 and here 3 over 2 and here 1 and here 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 factors. Equality only comes with numerators. Then minus 5 possible equality, 2/3 possible equality, and 2 possible equality. Here not equal. Get table 2, 2, 1, 1, 3 over 2, 3 over 2, 0, 0, minus 5, minus 5. Here these are the columns. Headers here. Okay. Then check signs. Now you start with minus 5, that is x plus 5. No? Then 0 mean x. Then 3 over 2 mean 2x minus 3. Then 1 mean x minus 1. Then 2 mean x minus 2. Then minus plus 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 minus minus plus 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 minus 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 plus 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 minus 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 plus plus minus 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 plus. Okay. Then the important thing, you have to factorize it. Here 3 over 2, 1. Here 1. Here 3 over 2. No? Here equality. Here not equal. No? Okay. Then here 0 to 1. 1 to 3 over 2. No? Here 3 over 2. Then equality for minus 5. Equality for 0, 1, no equality, 3 over 2, 3 over 2, 2 and 2. Okay. So first you have to factorize numerator and denominator. Then leading term must be positive for each factor. No? Leading term must be positive. Otherwise, we can't put this say. Okay. So definitely have to initiate with that steps. Then finally here we have to check that rational relation x plus 5, 2x minus 3, x minus 2 over x minus 1. Then here start with plus minus plus minus plus minus. Then negative regions. No? Then here 1, here another 1, here another 1. No? Then select them, headers will be the solutions. No? And write final answer. X real value, x such that x less than minus 5, x less than equal minus 5 union 0 to 1, x in between 0 to 1, union x greater than 2 or equal to. No? That's how we do. Complete. Okay, then last one, x minus 3, x minus 2, x minus 1, x plus 1, x plus 2. We have 6 factor and further we have equality, no? Further we have equality. Then first you mark that on a number line. Here number line minus 2, minus 1, 0, 1, 2, 3. 1, 2, 3. Then three, 3, 2, 2, 1, 1, 0, 0, minus 1, minus 1, minus 2, less than, in between minus 1 to 0. Then no equality for denominators, then 1, 2, 3, okay. 1, 2, 3, okay. Here these are denominator. Then equality comes with 1, 2, and 3, no? Remove denominator zeros. Now start with here x plus 2, then x plus 1, then x minus 1, x minus 2, x minus 3. Minus plus 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 minus minus plus 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 minus 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 plus 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 minus 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 plus 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 minus, then minus minus minus, then minus minus plus, no? Okay, then here you have to think with x minus 3, x minus 2, x minus 1 over x plus 1, x plus 2. Then here plus minus plus minus plus minus plus. Then positive regions here, 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 and here. Then final answer, x element of real set x such that x less than minus 2 union minus 1 to 0, 1 to 2, greater than 3. Okay, complete. Further, we have to practice some questions with rational inequalities. Then later we can go to modulus inequality part. Okay. Okay. Now you start doing these questions. I'll give you Okay, you do these rational type inequalities. I told you, you can't cross multiply, okay? You can't cross multiply. You need to take all terms one side and simplify first. Okay, thereafter we can go to that evaluation. Shortcut method, okay, that number line technique, okay for now. Okay, then do it. So this is 2013 A-level question. Last one, here 2013 one. 2013 A-level question is this. Simple one. Okay, if you have doubt, first question do with me, others do alone. 5 over 5x minus 1, 2 over 2x plus 1. We can't cross multiply. You take here this side 5 over 5x minus 1 minus 2 over 2x plus 1. You can put all terms one side, then get common denominator. 5x minus 1, 2x plus 1, here 5 into 2x plus 1, 2 into 5x minus 1 greater than 0. Then 10x cancel, 5, 7. 5x minus 1, 2x plus 1. Okay, when you evaluate in rational inequality, you have to take all terms one side and again you have to factorize it. No? Take all terms one side and factorize it. Now, here you take all terms one side, get common denominator, and numerator and denominator you factor. Here we don't have numerator factors, then no worries about that. Mark real number line, here zeros, minus half and 1/5. No? We don't have equality. Then here positive, negative, positive. We need positive regions. Shade it. Then final answer, x element of real set x such that x less than minus half union x greater than 1/5. No? That's how we do. Continue now. Continue. Check your answers. Second one, 3x minus 5 over x plus 1 less than or equal to. Take two other side. Get common denominator. 2x minus 2, x minus 7, x plus 1. So we have equal here. Denominator zeros have to remove. No? Minus 1, 7 equal to for 7, not for this. The negative region is here. Minus 1 to 7 with equal 7. Final answer you write within curly brackets. Then 2x plus 1 over x minus 3 less than or equal 1. 2x plus 1 x minus 3 minus 1 less than or equal 0. X minus 3 2x plus 1 minus 6 plus 3. X plus 4 x minus 3 less than or equal 0. Here minus 4 3 equal to 4 minus 4 only. The negative regions here. Minus 4 to 3. Then 3x minus 1 x minus 1 less than 2. 3x minus 1 over x minus 1 minus 2 less than 0. 3x minus 1 minus 2x plus 2. X minus 1 x plus 1 over x minus 1 less than 0. Here zeros minus 1 1. Negative region here, no equality. Minus 1 to 1. Okay. Then x over x plus 4 less than 2. X over x plus 4 less than 2. Take this one here. 2x plus 8 minus x, x plus 4, x plus 8, x plus 4 greater than 0, no equality. Minus 8 minus 4. Positive, positive, negative. Here positive, positive region. Check your answers. Then last one, 2013 A-level question. That is given 2x plus 1, 3x minus 1 greater than or equal 1. Put this on the other side. 1 minus 2x plus 1 over 3x minus 1. Get common denominator. 3x minus 1 minus 2x minus 1. X minus 2. 3x minus 1 less than or equal 0. Real number line. Here 1/3. Here 2. Equality for 2 only. Then negative region is this. X in between 1/3 to 2 with equal to, no? Check your answers. Okay, now you come to these questions. All are rational type. Here, rational double inequality. Start them. Same procedure. Same procedure. Somewhat harder than previous one because simplification somewhat hard. But anyway, the procedure is same. You take all terms one side, get common denominator, and thereafter you factorize. First one very simple, it is first one linear one, okay? But the others are rational, but simplification somewhat hard. But anyway, take all terms one side and factorize numerator and denominator and go along that path. Do it. Check your answers. Check your answers. Question number 7 given x minus 3 over 4 minus 6 x minus 1 over 2 x minus 2 over 3, no? X minus 2 over 3. Linear inequality. Then you simplify first, take common denominator. X minus 3 minus 4x over 4. Here common denominator 6. 3 into x minus 1 2 into x minus 2. Here minus 3 minus 3x or 4. Before that, simplify 2, 3. 3x, 2x, x minus 3 plus 4, 1. Then cross multiply. Minus 9 minus 9x, 2x plus 2. Here 11x minus 11, x greater than minus 1. X greater than minus 1. Okay. Finally, you write within curly bracket final answer. Then x element of real set x such that x greater than minus 1. It is not a rational inequality. Okay. Now, 8th one, x minus 1 over 4x plus 5. Check this one. X minus 1 over 4x plus 5 less than x minus 3 or 4x minus 3. 4x minus 3, okay? Now we can't cross multiply. We can't cross multiply. We need to take all terms one side, no? So let's take here x minus 1 over 4x plus 5, x minus 3 over 4x minus 3 less than 0. See this one? See this one? Now common denominator 4x plus 5, 4x minus 3, cross multiply, x minus 1, 4x minus 3, x minus 3, 4x plus 5 less than 0. Then we have factors in denominator. Here 4x squared minus 3 minus 7 x plus 3, 4x squared. Here 4x plus 5 x minus 3, no, 4x squared, 5, 12 minus 7, 15. 4x squared, 7x cancel. 3 plus 15, 18. 4x plus 5, 4x minus 3 less than 0. Then we can select. No need to think about numerator, no? Positive. Minus 5 over 4, 3 over 4. Here negative region. Then final answer, x element of real set x such that x in between 3/4 to minus 5/4. That is 8th one. Check your answers. Huh? Okay. Then question number 9. Question number 9. Here x square minus 4 of x less than or equal 3. Check this. Take 3 other side, x square minus 4 of x minus 3 less than 0. Okay, now x square minus 4x minus 3. Then get common denominator x square minus 4 minus 3x of x less than or equal 0. X 4 1 minus plus. So now here minus 1 0 4 equals 4 equals minus 1 0. Remove denominator zeros. Then negative region here and here. Then x element of real set x such that x less than or equal minus 1 union x in between 0 to 4 with equals 4, no? Then 10th one, here given 2 4x squared minus 1 over x squared 3. Now this is double inequality, no? Double inequality. We have done this, that, no? X square we know surely positive relation and can be 0, no? You take x not equal 0 first, remember it. Then we can cross multiply because x square positive. Then 2x squared, 4x squared minus 1, 3x squared. Now double inequality you split 2x squared, 4x squared minus 1 intersection 4x squared minus 1 less than 3x squared. Okay? Double inequality. You have to separate with intersection. No? Now solve this. 2x squared minus 1 greater than or equal greater than 0. Here root 2x minus 1, root 2x plus 1. Here region minus 1 over root 2 plus 1 over root 2. Positive region here and here. Then for this x squared minus 1 less than 0, x minus 1 plus 1. Here minus 1 plus 1, negative, positive, positive, here it is. Then finally get common region, finally you get common region. See this? Then you mark everything on same number line, minus 1, plus 1, so this inner region. Then here 1 over root 2. Root 2 mean around 1.4, around 1.4. Then 1 over 1.4 mean point less than 1, no? Then somewhere here. 1 over root 2 somewhere here. Then 1 over root 2 again somewhere here, no? Minus 1 over root 2. Then greater than, less than. Then common region here and here. Common region. Then final answer, x element of real set x such that x in between minus 1 to minus 1 over root 2. Again union 1 over root 2 to 1 region. We have two different regions. So anyway, when we have double inequality, you separate them with intersections. Thereafter evaluate one by one. Finally get common region. That is general technique. Do it. Then last one, again double inequality. Check your answers. So given here x over 2x minus 3 in between 1, 0 to 1. No? So anyway, you separate them with intersection sign. So separately evaluate. Here we can do no factors, factor form here. One side 0. Positive region here and here. No? For this one, take the other side. Now get common denominator. X minus 3, 2x minus 3. Here positive region 3, 3 over 2. Here positive, positive. Then finally you have to get common region. So mark them on same number line. Here 0, 3 over 2, less than 0, greater than 3 over 2. Then 3 over 2 and 3. Then less than 3 over 2, greater than 3. Then common region less than 0 and greater than 3. Okay, complete them. Okay, now let's do another 2-3 questions. Then we can go to modulus inequality part. Let's do only 2-3 questions. Okay, you do these questions later. Now put new subtopic, new topic, modulus functions and modulus inequalities. Write down new topic, modulus functions and modulus inequalities. New topic, modulus functions and modulus inequalities. Modulus functions and modulus inequalities. Okay, you do these questions later. Okay, when we are doing functions, we have done some introduction about modulus functions, no? We have done some little introduction about modulus functions. Then here we need to discuss many things and many special things with modulus functions. So function has polynomial type, rational type, irrational type, and so on, logarithm is so on. We have different types of functions. And usually modulus functions comes with polynomial and rational type. But with all the others there can be modulus. With all the others there can be modulus. But usually under A levels, usually modulus inequality comes with polynomials and rational type. Then modulus function means any function with modulus sign. Any function with modulus sign we call a modulus function. Then you identify generally identify minus 5 plus 5. Here these are different things, no? Minus 5 and plus 5 different. Then minus 5 value of minus 5 equal value of plus 5. So value mean we have neglect sign, no? So instead of this value we say minus 5 modulus. Here parallel lines. Here plus 5 modulus, they are same. Then minus 5 modulus plus 5 modulus same. Here we say minus 5 modulus equal plus 5 modulus. So getting modulus means removing sign. Getting modulus means removing sign, especially negative sign. So we can remove minus sign by this. But for plus, no need to remove that one because value is always positive. Value is always positive. That means negative effect with modulus. Okay, negative will be affected with modulus. This is about modulus. Then here general definition. Definition of modulus. Then there are some functions like y equal x modulus x. Here modulus function. Y equal x minus 1 modulus plus 2. Then y equal x minus 1 modulus, x minus 2 modulus, likewise addition of 3 modulus functions. Then y equal x of x minus 1 modulus type. There are different modulus type. Y equal x square minus 1 modulus. So getting modulus means we have to reset minus sign to plus. Here these are modulus functions. Then inequality with modulus function we call modulus inequality. That's it. Inequality with modulus function we call modulus inequality. Here we have two different techniques to evaluate it. We have two different techniques to evaluate modulus function. One is algebraic method, the other one is geometric method. So geometric method is the most important one. Geometric method is the most important one. Then for our A level, part A, there will be modulus type question. Usually modulus inequality. So 2011 to 2024 past papers. So part A there will be modulus question, inequality question. So only 2013, it was not modulus inequality type. That was rational inequality. We have done previously, no? Rational inequality type. Then 2024 A-level question, it has modulus but no inequality type. Yeah, special again, no inequality but it contains modulus. All the other cases, 2011 to 2024, it contains modulus inequality. 2011 to 24 all are modulus without this, but here it contains modulus but no inequality. Okay, then this is very important relation, modulus, because directly target to your A-level question. Okay, just write this definition first. Just write. Okay, now you write an inequality with modulus function, an inequality with modulus function, an inequality with modulus function is a modulus inequality. An inequality with modulus functions is an modulus inequality. There are two different techniques to evaluate it. First one, algebraic method. Second one, geometric method. First one, algebraic method. Second one, geometric method. Okay, Now let's see one by one. Okay, now see this. So let's discuss about linear function with modulus. That is the fundamental thing. Okay, check this. Y equal modulus x. Y equal x minus 1 modulus. Y equal x minus 2 modulus. Y equal x plus 1 modulus. These are modulus functions. Okay, general one. Within that modulus we have linear type, no? X to the power 1 means linear. So here there can be quadratic type, cubic type, rational type. There can be different type, but linear one is the most important one within modulus. Okay, usually there will be linear one within modulus in your A level. Now see, so here within modulus variables we have no independent variable x, here independent variable x. So within modulus there can be positive values, there can be negative values, there can be zeros. But when we consider outside, then that contain zeros and positive values only, no negative values. Okay. So when you consider outside, then that value will be positive or zero. But inside there can be positive or negative. So when you consider this, sign change here at 0, no? Greater than 0, this part positive, less than 0, negative. Then sign change at 0. When you consider this, sign change at 1, no? So when you consider this, sign change at 2, no? So when you consider this, sign change at minus 1, no? Greater than 2, positive, less than 2, negative. I mean within modulus, okay? Not outside. So thereafter, we can write some definition to get that one. So put curly bracket here. We have two segments now. X greater than 0 and x less than 0. We have two segments. Then you better to write x equals 0 as well. And for this case, x greater than 1, x greater than 1, x less than 1, and x equals 1. Then we can cover full number line, no? Then for this case, x greater than 2, x less than 2, x equal 2, no? Likewise, we can identify different regions. For this one, x greater than minus 1, x less than minus 1, x equal minus 1. Likewise, we can identify different regions. So now you think, huh? So for modulus, for positive values, modulus, it is useless thing. Plus 5 modulus, just useless. But minus 5 modulus, very important. Minus 5 modulus means plus 5. Plus 5 modulus means plus 5, no? Did you get it? Then for positive value, no need to put modulus. But for negative value, completely different sign will appear, no? After putting modulus. Therefore, when you consider x greater than 0, we know they are positive values, no? Then here within modulus we get positive values. Then no need to put modulus, no? So you think here plus 5 modulus, we get plus 5. But minus 5 modulus, we get plus 5, no? Then this is really important, but for this one, no need to put modulus. Then if we know exactly it is positive, then no need to put modulus. So now you think here, x greater than 0, here this part positive, then no need to put modulus sign. You just write x only. For x less than 0 region, here this one negative, no? We need to reverse the sign. Negative need to convert to positive, no? Then you put another minus outside. Then x less than 0 mean here negative value. With this one, minus get plus, ne? Less than 0, x value negative. And with this one, then that will again convert to plus. When you put x equals 0 here, we get 0. Then for x greater than 1, this is positive, then no need modulus sign. X less than 1, here this part negative, then by modulus sign we need to convert that into positive. Then x minus 1 negative, you put again minus outside, then here negative into minus, we get positive, no? Then when x equal 1, 0. X greater than 2, positive, x less than 2, negative, x equal to 0. X greater than minus 1, positive, x less than minus 1, negative, and x equal minus 1, 0. That's how we write definition of modulus. Okay. First you do up to that. Here somewhere you write modulus with linear functions. Modulus with linear functions. Write them. Modulus with linear functions. You write them one after the other. So by the side you need some space to sketch the function. Okay, by the side you need to sketch this function. Okay, then you do one by one downward. Okay, now let's see how to sketch them. Let's see how to sketch them. Here x-axis, y-axis. See my way. See my working rule. Here, this is y, and this is x. Usually x comes front, ne? So usually we write x coordinate beginning, no? Then secondary one will be y coordinate, but here somewhat different. Here x and here y. Then you take coordinate 0, 0 first. Here this is coordinate 0, 0, mark it. Here 0, 0, mark. Then you think here y equal x, Then y equal graph 45 inclination, no? Y equal x means 45-degree inclination line. Here y equal x. Then that line only possible with x greater than 0 region. So x greater than 0 means here positive region. Then you take this portion only. Then this graph type we call piecewise type. So here this piece belongs to this region. This piece belongs to this region. Likewise, these are piecewise functions. Then y equal x for x greater than 0. Here y equal x for x greater than 0. Here y equal minus x. Minus x this way, no? Straight line. So that belongs to less than 0 range. Here y equal minus x. Then for like negative region, for this region. That's how we sketch. So while we are doing functions, I told you how to directly sketch modulus function. So we sketch general one, thereafter we reverse negative to positive, no? We reverse negative to positive. We get mirror image. So here another technique. Then here take here x-axis, y-axis. Here 1, 0 point, mark it. Here y equal x minus 1. Y equal x minus 1 for greater than 1 region, for this region. Y equal minus x plus 1. That is for less than 1 region, for this region only. Here 1 minus 1. See now, all y values are positive, no? All y values are positive. That is the property of modulus. So see, now by practice you can directly sketch this way. 2, 0, mark 2, 0, and it is V-shape one. You sketch V-shape, intercept you take 2. So when you produce, you get minus 2 intercept. So now remember, linear function, modulus, V-shape graph. Now take this x-axis, y-axis. Here minus 1, 0, mark it. Then intercept 1, sketch V-shape. 1, minus 1. Now we can directly, easily sketch modulus function linear one, but the definition is that later we analyze this and we sketch the thing. But anyway, directly we can remember that one, how to sketch linear one. It is V-shape. You find vertex first, then thereafter sketch V-shape. Thereafter you see constant term, then you can find intercept. No? By the constant, you can directly analyze intercept, y-intercept. Okay, finally, by the side, sketch all of them. Okay. Now you see another one. Okay. You just try y equal x minus 3 modulus x plus 2 mod x plus 3 modulus y equal x minus 4 modulus y equal 2x minus 1 modulus. You try. You do alone. Okay, now this is very simple. Definition very important. But to sketch the graph, no need that definition. We can directly sketch because of that property. Okay. But anyway, you write definition. X greater than 3, x less than 3, x equal 3, x minus 3 minus x minus 3, 0. Then V-shaped graph, vertex at 3, intercept 3. Then here, x greater than minus 3, x less than minus 3, x equal minus 3, x plus 3 minus x plus 3, 0. Here x, y at minus 3 vertex, V shape, here cut at 3, minus 3. X greater than 4, x less than 4, x equals 4. X minus 4 minus x minus 4, 0. Here x, y, vertex 4, intercept 4, V shape. Here x greater than half, x less than half, x equal half. Then here 2x minus 1 minus 2x minus 1, 0. Here x-axis, y-axis, vertex half, intercept 1, here minus 1. That's how we do. Okay. Okay. Now with this definition, With the definition, we can evaluate modulus inequality. Okay, I'm going to do algebraic method now. Okay, subtopic modulus inequalities with algebraic method. 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 Okay. So we can complete today itself this algebraic method. So then you can do any modulus inequality type question by algebraic method. But the most important one is geometric method. That's the important one. But here I am doing algebraic method. See this one all. X minus 1 modulus greater than 2. See this one all. X minus 1 modulus greater than 2. Modulus inequality. Now here we have one modulus now. One modulus psi. Then there is only one critical value now. Check this one all. Now real number line. Here 0 value is 1. Mark it. Then we can see here two segments now. Greater than, less than. So I am going to write that modulus definition here. Check this one all. Now here minus infinity to 1 value there. Here 1 to infinity value there. To cover this full number line, I am going to put equal 1 here. Okay, only for 1. Don't put equal here also. Okay, you get only 1, only for 1. You can put here or here, because that we put to cover this full real axis. Okay, don't repeat it. Okay, okay. Now x less than 0, sorry, x less than 1. Here this part negative, no? For x less than 1, negative. Write same inequality as it is. For x greater than 1, this part positive. Write same inequality here with that sign. For greater than 1 positive, put positive sign and write it as it is. For less than 1, here this part negative, then put another minus sign to remove that. Write same inequality. Then you evaluate. We know how to evaluate linear one. Then x greater than 3. Here for this minus x plus 1 greater than 2 minus 1. Okay. Now we have two solutions for different regions. This solution belongs to here this region. This solution belongs to here this region. Okay. Then you take here this one and this one and get intersection. And similarly you take this one and take this one and get intersection. Do it now. Real number line, here greater than 3, here greater than 1. Then intersection means common region, no? X greater than 3. Then here x less than minus 1, x less than minus 1, and here x less than or equal 1. Then intersection means common region, that is x less than minus 1, no? Final one, these two you take and get union. Then final answer is that. Then x element of real set x such that x less than minus 1 union x greater than 3. That's it. First you see modulus inequality. We have only one modulus, mark 0 value here. Then there are two sections. Then according to that, get a table to cover full number line, put equality here or here. Then for this region, check the sign of modulus and write inequality and evaluate it. Then final answer, you have to take intersection with this column header with these two. You have to get intersection. Similar here, these two get intersection. Thereafter, these two you take union. That's how we evaluate the inequality, modulus inequality type. Okay, do that method, do that question. Okay, see another one. See another one. You follow same technique. X minus 1 modulus 2x plus 1. See this. X minus 1 modulus greater than 2x plus 1. First you see only about modulus, not with the others, okay? Here we have one modulus. So on the real number line, mark it 0 value 1. Don't think about the other, okay? Only with modulus sign you did take critical value. Now you get a table. Here 1, 1, greater than 1, less than 1. Then to cover number line, you put equal to here. We put this equal sign to cover number line, okay? Now for greater than 1, here this part positive. Don't worry about the other, that is not modulus, you write as it is. So we put sign to define modulus function, okay? Then less than 1, here this part negative. Then to remove that negative, you put minus sign again. Now you evaluate this one. 2x here, x minus 2. Here minus x plus 1, 2x plus 1. Here 3x, 0, x less than 0. So now we have two solution set. Then you take these two and get interception. Similarly, you take these two and get interception. Then final answer, you take union. No? Then do it x less than 0. X less than 1, x less than or equal 1. Then common region less than 0. Then here less than minus 2. Here greater than 1. We can't see common region, no? We can't see common region. For that case, we don't have real value. So finally, we don't have real value here. Finally, you take union of these two. Then no real value, no? You can just forget it. Then value less than 0 is the solution. Then final answer, x real value, x such that x less than 0. This is the only solution. Okay. Then same procedure. Do that example. Okay, try these questions. Try these questions. Do with algebraic method. Okay. Now we have done modulus inequalities algebraic method. Okay. You can complete them. Then further we have to do graphical method or geometrical method. Next day we can do that one. This is enough for today.